Hi, everybody. Today we're going to do part two of our review. And so let's get going on it. This is the part that deals with systems and matrices. Let me share the document that you received last time. Whoops. You received a document. Hang on a second. Things are a little messed up here. There we go. You received this document a couple of days ago. And so let's scroll up to the top. So the first thing you should be able to do is you should be able to use the RREF feature of your calculator. Okay, the second thing is if we do use the RREF feature of our calculator, we should be able to determine what the solution is to a dependent system, or we should be able to know if it's inconsistent. So if it's a dependent solution, this last row here is all going to be zeros. Okay? If it's inconsistent, they're going to have a 1 here in this last row and a 0 here. That means that z equals 1z. I'm sorry, you're going to have a 0 z equals 1. That makes no sense. 0 can't equal 1. Okay, what this does mean, though, is remember this is the x column, this is the y column, and this is the z column. Over here, we have the result. And so R1, which says 1, 0, 2.3, and 5, means x plus 2.3z equals 5. And R2 means that 0, 1, minus 4.2, and 6 means y minus 4.2z equals 6. We can isolate the x by subtracting 2.3z from both sides and getting x equals 5 minus 2.3z. We can isolate the y by adding 4.2z to this in this case, which means that 4.2z plus 6 equals y. What this final row means, where 0 equals 0, z can be any real number. So we pick a z, plug it in, we get an x and a y out. Okay? So that means z equals z. We should be able to use Gauss elimination on a matrix like this, on a system of equations like this, where we build the augmented matrix. So remember, the augmented matrix is the coefficients. So our first 3 rows and 3 columns are the x, y, and z coefficients. And then on the other side, we have the result. Okay? So remember, with the Gauss elimination method, we want to make zeros underneath this main diagonal. And we want ones down the main diagonal. Okay, so we have a 1 already here in this first entry. So we're going to make zeros underneath it. So the way we're going to do that is we're going to multiply R1 by -1 and add it to R2. We're going to multiply -1 and R1 and add it to R3. That gives us zeros underneath that 1. In the process, our next part would be, okay, making that a 1 and then clearing out the number underneath it, which is already 0, so we don't have to clear it out. So we're just going to make this 2 into a 1 by multiplying it by 1/2, the reciprocal. And so that gives us, in the second row, the first row is the same, third row is the same, but the second row becomes 1, 3, and 7. Now this last element here in this main diagonal, we want it to be 1. So the way we do that is multiply by the reciprocal of this number, which is 4. So we're going to multiply it by 1/4. So that gives us zeros underneath the main diagonal. The main diagonal is 1. This means z equals 3. Now, just like up here, that second row says x plus 3z equals, or y rather, plus 3z equals 7. So since we found out that z is 3, we plug it in and get y plus 9 equals 7. Subtract 9 from both sides and get -2. The first row means x minus 5y minus 2z equals 7. So we plug 3 in for z, minus 2 in for y, and we end up with x equaling 3. So our solution is x equal 3, y equal -2, and z equal 3. We should know how to do matrix operations like multiplication, scalar multiplication, addition, and subtraction. So the first one, a times c, make sure that the number of columns here match the number of rows in the second matrix we're multiplying out with. And so a times c, so basically we multiply row with column. So first row, first column gives us the first entry in our answer, which should be 1 times 2 plus 2 times -1 plus 3 times 3. 1 times 2, 2 times -1, 3 times 3. That's going to add up to be 9. The second entry here is going to be first row, second column. And so 1 times 3, 2 times 2, and 3 times -2, which we see here, that adds up to be 1. Then we do the same thing with the second row. Second row, first column, gives us the first entry here in our answer. So we take 2 times 2, 4 times -1, there's a -1, there's our 4, and then 1 times 3, that adds up to be 3. Then we take second row, second column, 2 times 3, right there, 4 times 2, right there, and 1 times -2. Add it up, multiply it out, add it up, we get 12. And then finally, the last row, same idea. Third row, first column, 2 times 1, or -1 times 2, I'm sorry, is -1 times 2. 3 times -1, 2 times 3, that adds up to be 1. Then our final entry here in that third row would be third row, second column. -1 times 3, 3 times 2, and 2 times -2. That adds up to be -1. So you should be able to do something like that. When we add and subtract using scalar multiplication, we multiply through with the scalar. In the second matrix, this matrix E, that gives us -12, 0, 16, 8, -8, and 4. Then we add the two matrices together. Remember, to add or subtract matrices, they have to have the same number of rows and columns. So both of these are 3 rows by 2 columns. So we end up with a -10, a 3, a 15, a 10, a -5, and a 2. Then A squared, same idea, row with column, row with column, row with column. The last thing we should be able to do for this test, the last couple of things, we should be able to do an inverse matrix. Inverse matrix for a 2 by 2 using the formula, okay, which is 1 over AD minus BC times the matrix, where we flip-flop these two elements on the diagonal, and we take the opposite element on the opposite diagonal. So we make these negative, and we flip-flop these. So in this case, with a 2, 1, 4 minus 2, this gives us, when we multiply this out, this is going to be -1/8. We distribute this through. It's scalar multiplication. We get 1/4 and 1/8 in the first row, 1/2 and -1/4 in the second row. We should be able to use our calculator to do a 3 by 3. We press second matrix, edit, put the 3 by 3 in, fill in the entries, press second and quit. Then lastly, press second matrix names, number 1 because we chose A, X inverse, press enter. Then, since it's probably going to be in decimal form, we want to press math 1, enter, and you should get this matrix. And then the last thing we should be able to do is we should be able to set up a matrix equation. So here's our system. A is the coefficient matrix for X, Y, and Z if we have a 3 by 3. X is the variables, X and Y, or X, Y, and Z. It's a column matrix. And then Y is the result. It's a column matrix as well. So this gives us the equation AX equals Y. So we have the 2 by 2 or the 3 by 3 times that column matrix of variables equals the result. And this can be solved by finding A inverse. So in this example, we found A inverse a couple of minutes ago. It's the 1/4, 1/8, 1/2, and -1/4 from above. Also recall that when we multiply a matrix with its inverse, or the inverse with the matrix, we get the identity matrix. The identity matrix doesn't change anything. We multiply A with the identity, we get A. We multiply the identity with A, we get A. And so that means that in this equation, this AX equals Y equation, if we multiply both sides by the inverse, okay, so A inverse A times X and A inverse Y, we get the identity times X, which is just X, and it equals A inverse times Y. So the solution to a system of equations can be found by taking the coefficient matrix and multiplying it by its inverse, by the result by its inverse. Okay? And so in this case, this gives us the 1/4, 1/8, 1/2, and minus 1/4 times the minus 3 and 10. Now we're going to multiply this the same way we did before. We're just going to have one entry here though, because we're going to multiply first row with this column. So 1/4 times minus 3 plus 1/8 times 10. That adds up to be 1/2. So that's what x is. Y is found by taking this first row, the second row, and multiplying it with this answer column. So 1/2 times minus 3 and 1/4 times 10. That adds up to be minus 4. So x is 1/2, y is minus 4. If you can do these problems along with the other review that we saw, you shouldn't have really any problems with your test. Okay, your test runs from the 20th to the 23rd. If you have any questions, make sure to ask. Have a good day.